Welcome to the Transum Podcast, a monthly roundup of the new features on the transum.org website, providing mathematical puzzles, games, learning activities, and the ever-popular mathematics lesson starter of the day. Here's your host, John Tranter.
Hello, and welcome to podcast number 63 for the month of February 2020. A month with 29 days, due to the fact that this is a leap year. And yes, there is a starter of the day for the 29th of February. Wait for it. But the other interesting fact is that on the 2nd of February, the date, sort of written in a short format, will be palindromic. That means it reads the same forwards as backwards. So it'll be 02022020. That will be the date on the 2nd of February. Amazing maths fact for you to throw into your maths lesson on the 2nd. Well, that is if you go to school on Sundays, because unfortunately it falls on a Sunday. But nevertheless, it's interesting. So let's move on to the puzzle of the month. The number 57 came up as the answer to a worked example on the board. One of my secondary school pupils, Carl, mentioned that this was the product of his parents' ages divided by the double of his age. He also threw in the fact that his father was 5 years older than his mother. So how old was Carl? Well, while you think about that, here are some of the key resources added to the Transum website during this last month. Awesome! That's the title of a new puzzle, which is a little more difficult than I thought. I uploaded it confident that the logic of my method was correct, but no, the correct solution eluded me until after I had uploaded it. Can you find the largest awesome? You have the digits 1 to 9, and you have to arrange them in a 3x3 grid, so that the rows make 3-digit numbers, and so do the columns. And if you add the 3 horizontal 3-digit numbers and subtract the 3 vertical 3-digit numbers, the answer you get is the awesome. And the idea is to try and maximize that to get the biggest possible awesome. So I bet that when you first try it, you start off by using the same incorrect strategy that I did. Anyway, let me know how you get on. And the link to this and the other activities I'm talking about are in the newsletter, transum.org/newsletter. And of course, subscribers, you get the answer at the bottom of the puzzle page. So anyway, let me know how you get on. I think the puzzle is a great teaching resource. It makes pupils think of the relevance of place value while devising a strategy. It reinforces the algorithm for adding 3-digit numbers, but goes much deeper than mere drill and practice. Give your pupils the clue to consider the effect of the result of putting a number into each of the different cells on the grid. And it's quite surprising the effect that different positions have on the final outcome. So I think it makes learning mathematics exciting, enjoyable, and rewarding. Can you tell I really like this resource? I've used it a couple of times and it's gone really well. So it's called Awesome.
You are listening to the Transum Podcast. You can find Transum Mathematics at www.transum.org.
Okay, I've made a new help video for the changing the subject exercises, which will hopefully make the resource more useful as a homework assignment. The video isn't intended to teach rearranging formula from scratch, but it should be a helpful reminder for those who have learned and forgotten. Okay, I've just finished designing the Perfect Magic Square puzzles. There are 9 levels of difficulty determined by the number of clues given, and the clues are basically the numbers already in the correct position. And it never ceases to amaze me the complexity of a 4x4 perfect or pan-diagonal magic square. There are so many groups of 4 numbers that sum to the magic total, and as such it does actually make it easy to complete partially completed puzzles. So that might be for you or your students. And because I guess in addition to the fun of developing a solving strategy, there is such a lot of opportunity to practice mental methods for addition and subtraction. So it makes the resource a great alternative to the traditional numeracy exercises for children of all ages.
All passengers and cabin crew should now be seated with their seatbelts securely fastened. The cabin lights will remain dim for landing.
I managed to get an emergency exit row seat on my long flight at the beginning of January, which meant I could use my laptop to develop the Flabbergasted starter into a game. A shout out to the dentist who sat next to me during the flight and was talked into being the first to play the completed Flabbergasted game, despite the fact that he beat me. Anyway, have a go at that. Links in the newsletter. The puzzle that inspired my next creation involved the numbers 1 to 6. I adapted the whole numbers, though, to be twelfths, and then expressed them in their lowest terms, and voila, there we have circumfraction, a new puzzle involving fractions, and that's, again, available by a link in the newsletter. There then followed a whole collection of number placing puzzles that came flowing out of my computer. Goal products, triangled hexagram, hexagram star, and octagram star. Each have their own character, but are all variations on a theme. And it's hoped that strategies developed on one puzzle will transfer to another. I think my next job is going to be drawing up a table comparing the difficulties of each level of each puzzle, probably the number of degrees of freedom you have at the beginning, so that a suggested order ensuring progression can be deduced. Anyway, that's a future idea project. This time last year, I was talking in the podcast about the remainder race being mentioned on the Frank Skinner radio programme. I still think it is an excellent game, and for all of you who are private tutors, it's a fun way to spend the last 10 minutes of your one-to-one tutorial so that your students leave on a real high. The links in the newsletter, remainder race based on a really old game, the royal game of Ur. Have a look and see what you think. For future reference, there are 2 mirror sites that contain all the Transom starters and activities. They are at www.transom.com and www.transom.info. The only difference is that they don't contain details of the subscribers, so you can't actually log into those sites, but you can still do all the activities. So if there ever is a problem with transom.org, and it seems to be going to be a long time before it comes back online, I will transfer the database containing subscriber details to transom.com, so eventually you'll be able to log on there too. Valentine's Day falls in February. And if you want to prove that you are a real trendy teacher, you could surprise your pupils with one of 2 Valentine-themed starters on the 14th of February. Valentine's Puzzle is one, and Love Maths is the other. How cute is that? Anyway, now the solution of the puzzle of the month. About Carl saying the number 57. It was the result of multiplying together his parents' ages and dividing by the double of his own age. And his parents, one was 5 years older than the other. So, let me make it clear first that this situation is totally fictitious. I've never had a student come up with such a statement in the middle of my maths lesson. It's only in the world of maths problems that pupils come up with such statements. And I named the imaginary pupil Carl as a nod to the mathematician Carl Friedrich Gauss. So I began my solution by letting Carl's age be C, which has to be an integer, between 10 and 18 because he's at secondary school. So the product of his parents' ages divided by 2C is 57. One equation and two unknowns. So I need to be a little bit creative here. So the product of his parents' ages, multiplying both sides by 2C, is 114C, which I then factorise to get 2 times 3 times 19 times C. And then I had to have a little play around looking for pairs of these factors, which would give two numbers that differ by 5, and worked out that, of course, C had to be between 10 and 18. So I came up with 2 times 19 as one of the numbers, and 3 times C as the other. So either 38 is equal to 3C minus 5, but there was no integer solution for that, or 38 equals 3C plus 5. And that gave me a nice solution of C equals 11. So my solution is that Carl's age is 11 and his parents are 38 and 33. Of course, that solution is in the newsletter, if you didn't quite keep up with what I was rambling on about there. And let's hope you got that answer as well. I actually checked the answer was correct by doing a brute force check of all possible fathers' and mothers' ages using a spreadsheet, which is quite easy to do. So, yes, I'm convinced that's the right answer. That's all for now. See you next month. Bye.
Thank you for downloading and listening to the Transum podcast. You can find the website at www.transum.org, where you're welcome to use all of the activities absolutely free, or jump in with both feet and become a Transum subscriber.